Welcome to Pure 2, Chapter 3.3, where we look into geometric sequences. So before we start, okay, let me ask you, can you pause the video and write down the formula for the arithmetic sequence and the arithmetic series formula? You've learned two of the formula before. Pause the video, write them down. It's just a quick quiz. So the sequence is un equals a plus n minus 1 times d, and the series is Sn equals n over 2 bracket 2a plus bracket n minus 1 times d. Okay, so geometric sequences. So geometric sequences is one with which there is, so which there, oops, there is a common ratio between terms. Well, in simple terms, it means we're multiplying, dividing by the same number each time. So in here, we can see we're multiplying by 2 each time. So we say R equals to 2. Okay? Right. Can you identify the common ratio R? Can you write down the ratio for each of the question? Pause the video, have a go. When you're ready for the answer, you can press play. Here are the answers. Simple as. Okay, you multiply by these numbers each term by term. Question 4, where it looks like tricky, but you actually multiply by -1. Or question 2, we can't write divide, so we multiply by 2/3 each time. So here's the ratios. Okay, right, so the geometric sequence, okay, the nth term, again, another formula. So for the geometric sequence, the un equals ar to the power of n minus 1. So now you've learned the third formula. If you remember what I said, there are 5 formulas you have to learn. Here's the third one. Un equals ar to the power of n minus 1, where r is the common ratio. Yeah, okay. Right, so example, determine the nth term and the 10th term of the following sequences. Easy peasy. Once we work out, okay, this is a geometric sequence because we can see we multiply by 2 each time. So then un equals ar to the power of n minus 1. We know a is the first term, 3. Ratio is 2 because we multiply by 2 each time, 2 to the power of n minus 1. Now, can we simplify this? No, we can't because they have different power. For example, if I ask you this, x squared times y cubed, can we simplify into xy to the power of 6? Of course we can't. Okay, so I know it's tempting to write something like 6 to the power of n minus 1, but we can't do that. Okay, so that's the nth term. For the 10th term, u10 equals to 3 times 2 to the power of 10 minus 1, which, if I use my mental maths, aka my calculator, is 1536. Simple. It takes me no seconds to work it out. 2 to the power of 9, obviously, divide by 3, or times 3, of course, is 13536. If you can't do it in 5 seconds, you should learn your mental maths better. Just kidding. So part B, okay, let's do this. Un equals ar to the power of n minus 1. So un equals, the first term is 40. Now ratio, you can see we're multiplying by -1/2 each time. It's negative because you can see plus, negative, the sign alternates. So we know the ratio has to be negative. And then 40 times a half, etc. So times -1/2 of n minus 1. And that's fine. We can leave it as it is. Okay. Again, you can't simplify 40 and a half because the half is a power. So u10 equals 40 times -1/2 to the power of 10 minus 1. Again, mental maths. Oh, yes, it's -5 over 64. This one takes me 6 seconds rather than 5 seconds. I'm just going to use the calculator. Okay, right. So one example. Okay. Is this an example? Yep. Hang on. Did I just rearrange the? Did I just rearrange the? Sorry, I think I accidentally moved the pages around. Anyway, example. The second term of a geometric sequence is 4, and the fourth term is 8. Given the common ratio is positive, find the exact value of the 11th term. So in here, we can use two methods. Okay, the first method is we use the method by books, which is by the formula. So if we use the formula, method number 1, use formula, okay, then what we know is the second term is 4. That means u2 equals 4. So u2, okay, also equals to ar to the power of 3 minus 1. So we can write ar to the power of 2 equals 4. Okay, that's the first equation. Next one, fourth term is 8. So u4 equals 8, which also equals to ar to the power of 4 minus 1. So ar cubed equals 8. So from here, we can then do simultaneous equation. So simultaneous equation. Okay, I'm just going to call this equation A and equation B. Okay, so if I do equation B divided by equation A, you will see now why divide? Because A divided by A is gone, R cubed divided by R squared is R. So I'm going to write AR cubed over AR squared equals 8 over 4. So A and A cancel out, R equals 2. Well, R equals 2, then we can work out A, right? So therefore, if R equals 2, 2 squared is 4, then A would be, am I right? Hang on. AR to the power 3 minus 1. Oh, I made a mistake in here. So I made a mistake. That should be 2 minus 1. I'm thinking that should be 2 minus. I was checking my notes. Why am I incorrect? So AR, my bad. So that should be a part of 1. So R equals to R squared equals to 2. Therefore, R equals to root 2. And if R equals root 2, then A will equals to 4 divided by root 2, which is 2 root 2. Okay, so then if I want to find 11th term, U11 will equals to 2 root 2 A R to the power of n minus 1. And if I put in the calculator, I get 64 root 2. Okay. Second method, okay, just count the terms. This is the method I would suggest you to do. Okay. Second term is 4. So if you think of first term, second term is 4. Something, and then the fourth term is 8. That means times something is 8. So this is much easier. So 4 times R squared is 8. So R squared equals 2, R equals root 2. If R equals root 2, you can work backwards, okay? Or you can think of A, the first term, times root 2 equals 4. So A must be 4 divided by root 2, which is 2 root 2, and the rest will be the same as that one. Okay, so I think this method is much easier when it comes to counting the terms. You can use both methods. You will see practice question will be something similar, so choose one wisely. I would say the second one. Right, next one. One more. Where's the practice question? Oh, right. Okay. So maybe this time you can, if you want to do it, if you feel like you are confident doing it, feel free to do so. As a practice, and you can play the video. That's the best thing about the videos. You can play and pause any time you feel confident and less confident. Example, the numbers 3x and x plus 6 form the first three terms of a geometric sequence with positive terms. Find the possible values of x. Now, remember, we've done something similar in the last lesson about arithmetic sequence and series, where was it? No, it's not here. Where was it? Where is it? I couldn't find it. I couldn't find it. Never mind. Never mind. So, well, what we know is 3x, x plus 6 something. If it's a geometric sequence, that means they multiply by the same term, by the same number, right? That means 3 times r equals x. Also, r x times r equals x plus 6. If we make r the subject, r equals to x over 3, and r equals to x plus 6 over x, then these two are equal. Right? Now you're struggling to understand what's going on here. Let me show you a different one. For example, 3, 9, 27. So what I'm trying to say is I know 9 divided by 3 is the same as 27 divided by 9 because they share the same ratio. That's what we've done. Second term over the first term is equal to the third term equals over the second term. From there, cross multiply to solve it. So x squared equals 3 bracket x plus 6. So x squared equals 3x plus 18. X squared minus 3x minus 18 equals 0. Solve for x. Put in the calculator. You should get x equals to 6 or minus 3. They did tell you actually, x has to be a positive term. Sorry, they are all positive terms, therefore x cannot be minus 3. So x equals 60 is the only possible value. Part B, find the 10th term. So 10th term, U10 equals A 3 times R to the power of n minus 1. So again, put in the calculator. AR, sorry, hang on. AR, hang on. Oh, sorry. X is 6, but R is not 6. So R is actually 2. Sorry, my bad. 2 to the power of 10 minus 1. So 3 times 2 to the power of 9, which is 1536. Mental maths again. Calculator. So be careful with that. I shouldn't be subbing in 6, which I did as a mistake very quickly. I quickly realized that's wrong. I don't know why, it's just my superpower. But if you don't have my superpower, you should check your answer carefully. So x is 6, but it's not r. R is 2 because 3 times 2 is 6 and 6 times 2 is 12. Okay, right. Again, pause the video if you want to do this question as a practice question. You should be able to do something similar. Okay, so what is the first term in the geometric progression? Progression means it's a sequence. Means we're not adding them together. That means which term will exceed 1,000,000? Okay, pause the video if you want to do that. So we know this one is the ratio is 2 and a is 3. So we can write un equals to a times r to the power of n minus 1. And that exceed 1,000,000. So 1,000,000 has 6 zeros. So 3 times 2 to the power of n minus 1 greater than 1,000,000. So I can do 2 to the power of n minus 1 greater than 1,000,000 divided by 3. And then to solve for n in the power, you should recall your knowledge on log or ln, depends which one you prefer. Doesn't really matter in here. We take ln on both sides because ln usually the preferred one. So if we take ln on both sides, 3, 4, 5, 6 over 3. Then we can take the n minus 1 down, ln 2 greater than, I'm going to skip writing that, divided by ln 2. So n minus 1 is greater than ln 1,000,000 divided by 3 divided by ln 2. So if I put that in a calculator, or aka the mental maths, let me try that. I get 18.34. Everyone should know that. And then n has to be greater than 19.34. Therefore, n equals 20. That means the 20th term, that the sequence will exceed 1,000,000. Right, practice. Finally, your turn. Okay, pause the video, have a go at the question. Okay, when you're ready for the answer, you can press play. There's the final answer. If you got it right, move on. Next practice. Okay, if you got it wrong, we'll go through why. Okay, I'm going to use the easy method, which is counter terms. The third term is 20, so something 20, and then fifth term is 80. So what's the 20th term? So let's work out the ratio. When it comes to a geometric sequence, all about the ratio. So times r times r. That means 20 times r squared equals 80. So r squared equals 4, r equals 2. So how do I not know it's minus 2? Because they say all terms are positive. That's why you ignore the negative 2. So if r is 2, then I can work backwards. That will be a 10, and that will be a 5. So you don't have to show them how you find a value. So u20 equals a r to the power of n minus 1. So a is 5. The ratio is 2 to the power of 20 minus 1. So which is 2621440. Okay. If you do want to use the formula method, you can. I'm just going to show you in here. I'm not going to through why. So a to the power of 4 equals 80, and ar to the power of 2 equals 20. Divide that, you get r squared equals to 4. Same thing. Okay. Right. Another practice question. Okay. Pause video. Have a go at question A, B, and C. When you're ready for the answer, you can press play. Here are the final answers. Go right. Good job. Well done. That's it for you. Chapter 3.3. But otherwise, let's go through. Okay. Question A. Again, geometric sequence. So what we know is they share a common ratio. So that means x plus 6 divided by x would have the same value of 5x plus 6 over x plus 6 because they share the same ratio. That means x times something is x plus 6, which is equivalent to x plus 6 times something, give us 5x minus 6. Right, so you can cross multiply, give you x plus 6 times x plus 6 equals x times 5x minus 6. Using a shortcut for expanding double bracket, x squared, 2 times x times 6 is 12x. 6 squared is 36, 5x squared minus 6x. You rejuggle with all the quadratics, you get 4x squared minus 18x minus 36 equals 0. I don't care simplifying, whatever. Just put a chuck in the calculator and calculate, give you minus 3 over 2 or 6. Okay, it's just like you got dirty clothes, give it to your mom. No hassle. Just kidding. I'm old enough to do my own laundry, just to make you aware. So x equals minus, so do you. x equals minus 3 over 2 or 6. Okay, the question didn't tell me is it positive negative, so I should include both answers. Okay, I should include both answers. Oops. A little accident in there. Anyway, let's back. So part B. Find it, given the common ratio is positive. So common ratio is positive. Find the common ratio. So if the common ratio is positive, that means there should be no negative terms. If there should be no negative terms, that means x has to be 6. So if x has to be 6, then 6, 12, 5 times 6 is 30. 30 minus 6 is 24. You can see we're doubling each time. So r equals 2. And C, hence determine the possible values. I'm not sure where the values come from for the first term. Oh, because there's a second term, third term, and a fourth term. Thinking, why is the first term not 6? Because that's a second term. So the first term will be 3, because 3 times 2 is 6. All right, and that's the end of the video.